In the last video, we already talked a little bit about some of our properties of logarithms, and that's these here, that if I have log base a of 1, it's always going to be 0, because a to the 0 power is always equal to 1. Log base a of a is always equal to 1, and so on and so forth. And I can take, if I think about what I have here, all right, the reason that this works, the reason they cancel each other out, is using the idea that if I have a property, log base a, the exponent, whatever's up here, can come down in front. So that would become, if that's an x, it's going to become x log base a of a, because a to the first gives me a out. So this becomes 1, and I just get x. Likewise, same idea, if it's in the exponent, the a and the log base a will cancel each other out. So these problems in example 1, we already did in the previous video. All right, so additional properties that we're going to look at. So one that I just said was this one right here, that if I have log base a of something to a power, I can put the power in front, or go the other way. If the number's in front, I can put it in the exponent. If I have, excuse me, if I have two logs of the same base added to each other, I can put them together by multiplying the stuff that you're taking the log of. If they're separated by a minus sign, I can divide the first one divided by the second one. And then we also have what we call a change of base. This was really important before your calculators were able to do. Like right now, you can actually plug in something like this, and it gives you out an answer. Back in the day, like when I was in school, I couldn't evaluate this on my calculator without having this change of base formula, which says I can just take log or ln or whatever I want to do, ln of 35 divided by the ln of the base, or log base 10 of m over log base 10 of a. Same idea. All right, so we're going to just look at using these properties to help us expand or condense, to rewrite so that it makes it simpler. So I'm going to treat these first as separate things. So I've got, it wants us to write as a single logarithm, which means I'm going to condense. Okay, so I see 3 log base 6 of x, so I'm going to use this property right here that says if I have a number out in front, I can rewrite it as log base 6 of x to the third power minus log base 6 of 2x. And then, last but not least, I'm going to use this one, that since they're separated by a minus sign and they're the same base, that I can write it as the one on the first one divided by the second one, and I'm going to go ahead and simplify. Actually, let's write it down below. So it's going to be log base 6 x cubed divided by x gives me x squared over 2. No, that didn't work very well, did it? So I get x log base 6 of x cubed over 2x, and then log base 6 of x squared over 2. There, that's a little better to read. All right, so for the second one, notice I have parentheses, so that means condense what's in the parentheses first, then we're going to condense with the first one. Okay, so, all right, so I have log base 3 of x minus, now I'm going to condense what's in here. I see both separated by a plus sign, but first I'm going to do my exponent piece. So the 2 is going to become the exponent. Okay, so then that's going to give me log base 3 of x minus, now I can put these together. Since it's a plus sign, I can multiply them. So that's going to become 12x squared. And now I can get rid of those parentheses because I've done everything that I can inside the parentheses. And now that they're separated by a minus sign, I'm going to use this one here that says I can divide this pieces. So they're both the same base, so log base 3 of x over 12x squared. And I can simplify that a little bit farther. X divided by x squared is 1 over, it's because the x is going to be in the bottom, so I'm going to have 1 over 12x. All right, let's move on to example 3. Now we're going to expand, so we're going to undo the properties. Okay, so first thing I see is that ultimately I have stuff divided by stuff, so I'm going to undo the divided by. So I've got log base 3 of 5x minus log base 3 of y to the 4th power. And if it helps you, put parentheses around it. So now the 5x is multiplication, so I can split that up into plus sign. So I've got log base 3 of 5 plus log base 3 of x. Now I've got minus, and since I have an exponent, that exponent can come down in front. So it's going to be minus 4 times log base 3 of y. And there's nothing more I can do with that. I mean, yes, I could evaluate that, but it's going to give me a gross decimal. So I'm going to leave it in log form because it's an exact form. All right, so now I've got natural log of all of this stuff. So first thing I'm going to do is rewrite the square root of 6 in here in fractional exponent form. So I know that that is, and I'm going to put brackets here, that's 6 to the 1/2. All right, so now ultimately I have stuff times stuff. So I'm going to write that as natural log of x minus 3 to the 5th power plus natural log of 6 to the 1/2 power. And now my powers can come down in front. So that's going to be 5 natural log of x minus 3 plus 1/2 natural log of 6. Now since this is an x minus 3, it's not a multiplication, it's not division, so I can't split that apart. It's just x minus 3. Okay, so I'm going to start this one for you, and then you're going to do it yourself. So I'm going to rewrite it as log base 5 of the quantity 5x to the 1/2 power over 3. So now I want you to expand it from there. Okay, so the next piece is asking us to rewrite in terms of log base 2 and log base 3. So I'm going to rewrite natural log of 6 as natural log of 2 times 3. And since it's multiplication using my rules, I've got natural log of 2 plus natural log of 3, which I could evaluate and get a decimal out. For b, I'm going to rewrite it as natural log of 2 divided by the quantity of 3 cubed, which that means I can rewrite it as natural log of 2 minus natural log of 3 cubed, which becomes finally natural log of 2 minus 3 natural log of 3. Okay, so I want you to try C. We've already talked a little bit about change of base, so it doesn't matter if I use log base 10 or natural log. To evaluate using change without just plugging it into my calculator, I would just do net log of 7 over log of 2, or natural log of 7 over natural log of 2. Okay, like I said, at one time, calculators like yours couldn't do this, so you had to do change of base in order to evaluate. So we'll do one more. For b, I can do natural log of 35 divided by natural log of 6, or log base 10 of 35 over log base 10 of 6, and so on and so forth. All right, so now we can get into starting to answer the types of questions that say, how long until I have $50,000 in my bank account, or how long before there's 2 million mosquitoes in the forest, or so on and so forth. Excuse me. So when I want to solve for an exponent, okay, what I'm going to do is I'm going to take, I personally just like using natural log, and the reason I do that, okay, is because later on it just becomes easier to solve. So in class we know that we could have written this as log base 3 of 11 equals x, which gets you to the same destination. Okay, so if I plug that into my calculator, I get out, what do I get out? Sorry. So log base 3 of 11, control enter, and I get x is about 2.183 when I round. The other way to do this, okay, if I didn't want to do that in that way, is to just take natural log of both sides. Okay, eventually this is going to make more sense to do it this way every time. So I have natural log of 7 to the x is equal to natural log of 0.75. Okay, so using my rules, I know the exponent's going to come down in front. So solving for x, I'm going to divide the natural log of 7 over. So I have natural log of 0.75 divided by natural log of 7. So if I do natural log of 0.75 divided by natural log of 7 and then hit control enter, I get x equals negative 0.148. Now had I done it the way we did in part A, I would have said log base 7 of 0.75 equals x, and if I did it that way, I get the same answer. But there are times that it's going to just make sense to do taking the natural log of both sides, and that's what we're going to get into in the next video.